This is part 3 of document number 5, in which we're going to be talking about functions for solving equations. In part 2, I cut my video short, and I wasn't able to discuss this function called Unisof. All what it does is when you have an argument with units, it extracts the units, but it does it using the units of the SI. So, for example, I put meters, it gives me meters. Kilometers, gives me meters. Feet gives me meters. Inches gives me meters. So basically what Unisof does is tell you what quantity you're dealing with, like length. And for example, if you say something like units of, say, 5 inch. Sorry, I'm trying to type inches here. Inches per second. Apostrophe second. It tells them what the units are meters per second. So that the utility of this function, as you can see it, is you determine what kind of basic SI units you have. Other than that, I don't see a whole lot of applications, but I just did it for the sake of completeness because I had them listed in my list of functions applicable to expressions. What I wanted to emphasize in this video is the functions for solving equations, and we have polyroots, roots, solve, and solve. Function polyroots is used to obtain the roots of a polynomial. You need to write your polynomial in increasing order of the independent variable, and then create a vector, a column vector, that will include those coefficients in increasing order of the x variable. There will be n plus 1 for a polynomial of order n, and this will give you your listing of all those roots. For example, this polynomial is a fifth order polynomial. I'm going to need 6 elements. I wrote it in increasing order of the independent variable powers. And so those correspond to 25, negative 5, 12, 28, 125. If you recall, to create a vector, I'm going to call it cvect. That's quite a complicated number. I'm just going to call it v. You go to this, or type Control M, select 6 rows, and put a 1 column, and then start entering the values from the coefficients. 25th to begin with, negative 5 for the second term, 12 for the third term, negative 28 for the fourth term, 125 for the fifth term, and negative 1023 for the last term. And then I is going to call the function polyroot, change the name of the vector to v, and you get those five roots for this particular polynomial. Let's check minus 5, 12, minus 20, minus 25, 10, 26. Right. All right. So that's very relatively simple. You can use it for any polynomial as long as you have the coefficients of the polynomial. The function roots. Function roots can be called in any of these forms. You need to have a vector of equations, a vector of variables that you're going to solve for, and in the second type of call, you need to have a guess of the variables. For example, I'm going to do this example one by moving this down. I'm going to work with x and y. So I clear it first. Clear x and y. It says equal to 1, that means it's been cleared. And then I type the equation. To type this equation, just simply type EQNS colon, Control M, 2 rows, tap 1 column, and then start typing x plus y minus 20. You have to type what will be the equivalent to the left-hand side of the equation so that it is equal to 0. X minus y minus 14. That's how I wrote EQNS. Vars is very simple, simply VARS, Control M, 2, tap 1, and then X, right arrow Y. Okay? And then I just say roots, equations, variables, and it gives me this result. Now this is a couple of linear equations, so it should be very straightforward. If you have a nonlinear set of equations like this one and this one, you may not find a solution right away. Why is that? Because basically it's a numerical process in which, in my understanding, is that when you apply it this way, you're starting close to 0. And so you may not converge to a result. So we need to provide an initial guess, a couple of numbers. To type this guess, you simply type GSS. You can give it any name, actually. Column, Control M, 2 rows, 1 column, and then type 1, right arrow, -4. Okay. And then when you call the function, just type roots, the vector of equations, the vector of variables, and the vector of guess initial values equals, and it gives you the result you look. Of course, it may be very sensitive to the initial guesses that you give, so you may have to try it several times to find the proper initial values to converge to a root, to a solution. In example 3, I have 3 equations, nonlinear. Clear the variables x, y, and z. Define the variables x, y, and z. Again, I get no division by 0. There's a problem with the initial guesses. Somehow you are dividing by 0. And so we try this initial guess, and I do find a solution. But if I try a different guess, I find another solution. A third guess here gives me no solution. And so you have to here try several initial guesses in applying this roots function. Finally, we have the function solve that we have presented before, in which is to solve a single equation and an unknown. You can write it like this, or you can limit your range of solutions to a low high. Some examples presented here: s times exponential of s Boolean equals sign 175 for s 3.558, solve s squared minus 5x plus 6. This value, if you go to tools and options and calculation and root ranges from -20 to 20, that's the default range, it misses a solution. A solution of 23.99 is beyond that range. And so if you add the arguments 0 to 100 to expand the range, you can find that particular solution. And so those 3 examples of functions that are readily available in SMath Studio will help you find roots of some equations. And with that, I conclude this presentation about functions for solving equations, which is the 3rd part of document number 5 of the Introduction Math Operations series.